Hello everyone. In this video, we will again discuss mesh analysis by solving one numerical. We have already discussed the basic of mesh analysis in previous video whose link I have given in the description box so you can watch it. So let's discuss the example. The question they have given is that for the network shown below, write down the mesh equilibrium equation. Okay, and for that they have given this type of network. You can see that this is the two voltage source are there. You can see this is the two voltage source are there. Similarly, they have given there are the four inductor L1, this is L2, this is L3, and this is L4. They also having a three capacitor C1, C2, and C3, and one wind resistance. Okay, so when we have discussed the basics of mesh analysis, I have told you that when we have to solve any question based on mesh analysis, we have to apply the four steps. The first step is always to find the how many meshes are there. In the second step, we will be assign the current direction to each mesh, and in third step, we will write down all the mesh equations. Okay, so I will start with the solution of this question. So the first step here is that find out number of mesh in the given network. Okay. So how many mesh are there that we have to find out in this network? If you see that this is the first mesh. Okay, so I will be giving this as a equation 1. Similarly, this will be mesh number 2. So I will be writing this as mesh number 2, and this will be mesh 3. So I will be writing now this will be mesh 3. So in this question we have 3 mesh. Fine. So this is the first, this is the second, and this is the third one. You can write this as a first, this as a second, this as a third. Name can be anywhere. Okay. Now, similarly, we will see the second step. What will be the second step? Second step is assign the current to each mesh with the direction. So I consider that let I1, I2, and I3 be the mesh currents. Okay. And we will follow the clockwise direction. Okay, so in the mesh 1 the value of current is I1, in the mesh 2 value of current is I2, and in the mesh 3 value of current is I3. Right, so I have marked all the three currents here, and we have to basically write down the mesh equation to all these three equations. Okay, so in the third step what we will do, we will write down all the KVL equations. Right, so this is the mesh 1, this is the mesh 2, and this will be the mesh 3. For that we will be write down the KVL equation. I have told you in previous lecture as that the voltage across resistance, voltage across inductor, and the voltage across capacitor. The voltage across resistance can be find out the product of current and resistance, and it is measured in volts. Similarly, the voltage across inductor is LP into I, that is its impedance value multiplied with the current. So this will be the measured in volt. Similarly, VC can be written as 1 upon Cp into I and measuring volts. So we will be using these three formulas: voltage across resistance, voltage across inductor, and voltage across capacitor, because this circuit is consist of resistance, inductance, and capacitor. So we simply use this KVL equation. Okay, so now we will see the fourth step. Sorry, in the third step, or we will write the KVL equation to loop 1 or the mesh 1. And what is the KVL equation? Summation of IR is equal to summation of E. Right? So if you see the mesh 1, the mesh 1 is consist of inductor, then capacitor, this capacitor and this inductor. Okay, so I will write for the first one, the value of inductor is L2. So what will be the current through this inductor? The value of the current through the inductor is I1. Okay, so it is simply L2P into I1. Okay, the value of inductor is L2 and we will write P, and what is the current here is I1. So the equation is L2P into I1 plus. Fine. Now second one is this capacitor. Okay, this capacitor you can see, but this capacitor is common to first and the third mesh. Okay, so what will be the current? This capacitor will carry the current of both the mesh, so that current is I1 minus I3. Okay, because we are considering the mesh 1, so I1 is greater as compared to I3. So what will be the capacitor voltage? Capacitor voltage is 1 upon Cp. So it will become 1 upon C1P, and value of current is I1 minus I3. Fine. Similarly, what will be the current through this C3? The value of the current through C3 capacitor is equal to I1 minus I2. Why? Because this capacitor C3 is common to first and second loop. So I1 is greater as compared to I2. So value of capacitance is 1 upon C3P multiplied by I1 minus I2. Right? Plus, because there is one another element L4. What is the current through L4? Again same, I1 minus I2. And how we will write the voltage across inductor? It is LP into I. So it will become L4P, and the values of current is I1 minus I2. Okay, so we have written all the summation of IR. Now what is the summation of E? So there is one voltage here. You can see that when we follow the clockwise direction, your negative plate will become positive, and we have seen that when negative plate become positive, it is voltage rise, and voltage rise is always taken as positive, and they should be equal to V1. So what we have done, we have applied the KVL to equation 1, and according to that we will get the answer of first KVL equation. Okay, now what we will do in the next step, we will rearrange the above equation. Okay, means we will collect the term of I1, I2 and I3 so that we can easily write in matrix form. So first collect the terms of I1. So it is L2P plus 1 upon C1P plus 1 upon C3P plus L4P. Right? So this is the I1. Similarly, collect the values of I2. So there is minus 1 upon C3P, and second term is minus L4P. This is I2. Similarly, I3. I3 is this one, minus 1 upon C1P I3, and this equal to V1, and we will write this as a equation number 1. So after applying a KVL to equation mesh 1, we will get this type of answer. Okay, now similarly we will write the equation for the second mesh and equation for the third mesh. Okay, so now I am writing the next one. Apply KVL equation to loop 2 or mesh 2. After applying, what we will get, that we have to see. Okay, so in the loop 2, what we have, in the loop 2 there is one inductor L3 Fine. Okay. So what will be the current in L3? L3 is common to second and third mesh. Okay. So now as we are writing for the second mesh, so larger current is I2. So what is the current here is I2 minus I3. Okay. So voltage will be L3P I2 minus I3. What is the current here? Current in the C2 is simply equal to I2, because here current is I2. And what is the value of current in resistance? The value of the current here is also same I2. And there is no voltage here. Okay. Now there are 1, 2, 3, 4, 5. 5 elements are there. Okay. Now when we write here, what is the current through L4 and C3? Because L4 and C3 is common to second and first mesh. So here current is simply I2 minus I1. Okay, as we are writing for second loop, so I2 is greater as compared to I1. So we have to write the 5 elements here. Okay, so first is L3. Okay, so I will write L3P I2 minus I3 plus. For what this C2? C2 is 1 upon C2P into I2. 1 upon C2P into I2 plus. What about the resistance? Resistance is I into R. So simply it is R1 into I2. R1 into I2 plus. Now there is this inductor. So it is L4P I2 minus I1. L4P I2 minus I1. And for this capacitor, which is C3, 1 upon C3P plus 1 upon C3P I2 minus I1. And this should be equal to EMF. Okay. But if you see that in the second loop, there is no EMF. Okay. So when there is no EMF, you have to simply substitute as 0. Fine. So we have collected 5 terms, 1, 2, 3, 4, 5. Now what we will do again, rearrange the above equation. Means ultimately what we have to collect the values of I1, I2 and I3 terms. Okay, so that we can easily write in matrix form. So first we will write about the I1. So it is minus 1 upon C3P, this one, minus L4P into I1 plus. Now next one, we can write down I2 terms. So I2 terms here is L3P plus 1 upon C2P plus R1 L4P plus 1 upon C3P. So it has 5 terms because second loop is consist of 5 elements. Okay, plus the last one is I3. So I3 is minus L3P and there is no other term of I3 and this equal to 0. So now this will be your KVL equation number 2, which is written for the mesh 2. Fine. Now similarly, we will apply the same method and find out the KVL equation for the loop number 3. Okay. So now I am writing down apply KVL equation to loop 3, and after applying that, what we will get, that we have to understood. Right. So we will see in the loop 3 we have 3 elements. This is L1. What is the current through this L1? L1 is I3. Fine. Now second element is L3. L3. So what will be the current here? The current here is now I3 minus I2, because now we are writing for third loop, so I3 will be greater as compared to I2. Now then we have another element. This one is a capacitor. So this capacitor is common to third and first mesh. So here current is I3 minus I1. Fine. So there are three elements and one EMF. So we can write. So for the first L3, it is L1P into I3. L1P into I3 plus. The second element is this inductor. So it is L3P I3 minus I2. L3P I3 minus I2 plus. There is one more element, capacitor. So it is 1 upon C1P. It is 1 upon C1P I3 minus I1. Okay, so we have written there are three elements, and the last one is EMF. So EMF, when you follow the clockwise direction, negative plate will become positive. So definitely it is voltage rise, and when there is voltage rise, we have to take it is as positive V2. So this is the KVL equation we have written for the third loop. Now rearrange above equation, means we have to collect the equation in terms of I1, I2 and I3. So first I will write I1. So it is minus 1 upon C1P I1 plus the next term we have to write for I2. For I2 it is minus L3P I2. For the third portion, it is L1P plus L3P plus 1 upon C1P, and this should be equal to V2. Fine. So now we write all the three equations for the three mesh. So this is the first equation for the mesh 1, this is the second equation for mesh 2, and the third equation for mesh 3. So now what we will do after that, we simply write all these three equations in a matrix form. Okay. Write down equation 1, 2 and 3 in matrix form. Okay, which I have told in a last lecture. Okay, so as there are three mesh, the size of matrices is 3 by 3. Okay, so in that way we have written these three equations for this given network. Okay, so